So in section 3.2, we are discussing logarithmic functions and their graphs. So in this section, we will learn about a new function called the logarithmic function. This is the function that is the inverse of the exponential function. So, for instance, when I have x plus 2 equals 4, we know that we can subtract 2 to solve for x. So we do the inverse of adding 2. When I have 2 times x equals 4, I know that I can divide by 2 because dividing by 2 is the inverse of multiplying by 2. So when I have x squared equals 4, I know that I can take the square root of x squared to solve for x because square rooting is the inverse of squaring, right? And much the same, if I have 2 to the x equals 4, then how do I get rid of the 2? And that's where we come to the logarithmic function. So, the logarithmic function. For x greater than 0, a greater than 0, and a not equal to 1, we can say that y equals the log base a of x if and only if x is equal to a to the y. So we have f of x equals the log base a of x. This is our new function. But let's go back up here to make sure that we understand the definition of a logarithmic function. So let's just put in some numbers, okay? So let's say that 3 is equal to the log base 2 of 8. So what does that mean? Well, if 3 is equal to the log base 2 of 8, then that means, well, look, okay, so let's look here. X is here, so that would mean 8. So 8 is equal to a. Now a is the base, so a is 2, so 2. And y in our problem is 3. So we would say 8 is 2 to the third. So yeah, that makes sense. 2 to the third is 8. So that means that the log base 2 of 8 is equal to 3. So let's try another example. The log base 2 of 16 is what? So the log base 2 of 16. Well, how do we figure out what that is? Well, we ask ourselves, 2 to what power is equal to 16? Well, that's pretty easy, right? 2 to the 4th. So the log base 2 of 16 is 4. Now, when we read this, okay, it says the function is read as the log base a of x. So when I have the log base 8 of 43, right, that's how I read it, log base 8 of 43. Now, we also have something called the natural log, and that is the logarithm of base e. Remember, e is what we discussed yesterday. So when I have the log base e of x, I actually just write the natural log of x. And yes, it says ln, but we read it as natural log. So when I write natural log, it is this implied base e. So if I write the natural log of x equals y, then we can say that e to the y equals x. So this is a very important thing to understand. This is the definition of logs. All right, so now it says, evaluate logs using the definition of logs. All right, so if I have the log base 3 of 9, so what does that equal? So the log base 3 of 9 equals what? Well, what does that mean? It means that 3 to the what power equals 9. So we ask ourselves, 3 to what power equals 9. That is how we figure out what the log base 3 of 9 is. And of course, 3 squared is 9, right? So the answer is 2. Log base 3 of 9 is 2. Why? Because 3 squared is 9. So you have to always go back to the definition of logs. So if I have the log base a of x equals y, then that means a to the y equals x, right? So you have to remember this. This is something that you should have memorized. All right, so the log base 5 of 125 equals what? So how do we tell ourselves how to figure this out? We say 5 to what power equals 125? And so, of course, then we think, well, 5 times 5 is 25, and 25 times another 5 is 125. And so that would mean 5 cubed is 125, so we get 3. Remember, we ask ourselves, 5 to what power equals 125? Okay? All right, the next one. 2 to what power is 0.125, right? Or the log base 2 of 0.125 equals what? Well, 2 to what power equals 0.125? Now, like I have said before, you might not know what that decimal is, so I'll tell you 0.0125 is 1/8. So now we're asking 2 to what power is 1/8? So now you recall that 2 to the third is 8. So what does that mean? Well, this is really like 8 to the negative first, isn't it? So 2 to what power is 8? Well, of course, that's the third. So the answer is 2 to the negative third is 1/8. Right? Remember, 2 to the negative 1/3 means 1 over 2 to the third, so that would be 1 over 8. All right? In the same way of thinking, if I have the log base 10 of 0.0001, then we can say that question mark and so we can write 10 to what power is 0.0001. Now, once again, we would want to rewrite this as a fraction. So 0.0001 is 1/10,000, right? So 1/10,000, right? But of course, 1 over 10,000 is really 10,000 to the negative first, right? So we're really saying 10 to what power is 10,000 to the negative first. So what does that mean? Well, we're looking for 10 to what power is 10,000. So 10 to the first is 10. 10 squared is 100. 10 cubed is 1,000. 10 to the fourth is 10,000. So 10 to the negative fourth would be 1,000 to the negative first. So the answer to this question is negative 4. So negative 4 here, negative 3 here, 3, and 2. So the definition of logs is the most important part in this section. All right, on to the next one. A couple properties of logs. The log base a of 1 is 0. The log base a of a is 1. A to the log base a of x equals x. And the log base a of a to the x is x. And then, lastly, if the log base a of x equals the log base a of y, then x equals y. So, the first one, why is the first one true? If I have the log base a of 1 equals 0, the definition of logs says that this is a to the 0 equals 1, right? So no matter what the base is, any base to the 0 power is always 1. So that means the log of any base of 1 is always equal to 0. The log base a of a is 1. Well, what does that mean? Well, that means, using the definition of logs, that a to the first equals a, right? Of course, anything to the first power is itself, so that's always going to be true. All right, now this one, in the same way of thinking, if I have a to the log base a of x, how is that going to be equal to x? Well, using the definition of logs. If I take this, the log base a of x, that equals something, right? So we're saying a to the what power is equal to x. Well, only if that power canceled out the log base a. So that would have to be, like if you look over here, a to the x equals a to the x, right? And so, of course, that makes sense. And so, basically, this number 3 is helping us to realize that the exponential base a and the log base a are inverses, and the log base a and the exponential base a are inverses, and so they essentially cancel each other out, leaving us just with x on both of those. All right, and then the last one, this one really isn't all that interesting. If I have the log base a of x equals the log base a of y, if you're doing the same thing to two different numbers, then of course those numbers must be the same. All right, so now it says solve each equation for x using the properties of logs. So if I have the log base 3 of 9, right? Property of logs says the log base 3 of 9. Well, the log base 3 of 9, well, 9 is actually 3 squared, isn't it? And so the log base 3 and the 3 cancel each other out. So we're left with 2, right? So 2 would be x, right? Or the other way you could think about it is 3 to what power? 3 to the x power is 9. Well, of course, x is 2. All right. On the right here, same idea, right, as we had over there. If I have the log base 5 of 5 to the 4th, of course, the log base 5 of 5 cancels itself out, and so we're left with 4, so x is 4. All right, over here, I have the log base 2 of x equals the log base 2 of 12. So, of course, the log base 2 of x and the log base 2 of 12, very simply, x must equal 12. Over here, just like the others, if I have the log base 3 of 3 to the x, then of course the log base 3 of 3 cancels out, and we're left with x equals 18. Now, the other way that you could do this is think about definition of logs. If I have 3 to the 18th equals 3 to the x, of course, x must be 18 if 3 to the 18th is equal to 3 to the x. All right, so now we're going to talk about graphs of logarithmic functions. So first thing we're going to do is we're going to create a table based on the definition of logs. And so we are using the log base 2 of x, but we're going to generalize it for basically anything the log base a of x. All right, so first of all, plug 0 in. So the log base 2 of 0. The log base 2 of 0. What is the log base 2 of 0? So what are we saying? We are saying 2 to what power is 0? And the answer is no power. 2 to no power is going to give us 0. So this is actually undefined. All right, now let's plug 1 in. Log base 2 of 1 equals what? So log base 2 of 1. So remember, this says 2 to what power equals 1? 2, well, to the 0 power equals 1. So we get 0. All right, next. The log base 2 of 2. So we're asking 2 to what power equals 2? Well, of course, 2 to the 1st. So the log base 2 of 2 is 1. All right, next, the log base 2 of 4. So I'm asking 2 to what power equals 4? So 2 squared, right? So this is 2. And then lastly, the log base 2 of 8. We've already talked about this. This says 2 to what power equals 8. So that would be the 3rd power, 2 to the 3rd. So we have 0 undefined. Well, we can't really plot that, but if we do recognize that an undefined value should be an asymptote or a whole, we'll talk about that more. Then we have 1, 0, 2, 1, 4, 2, 8, 3. So let's plot some of those points. We have 1, 0, 2, 1, 4, 2, and 8, 3. So we have this. Now, I'm drawing the rest of it in, but it would go down towards a vertical asymptote here. So there's a vertical asymptote at x equals 0. Now, what about for negative values? I didn't plug any negative values in. So let's do something on the side. What about the log base 2 of, I don't know, how about negative 1? What does that mean? Well, that would mean 2 to what power is negative 1? Well, 2 to no power could give us a negative or even a 0, right? So we can say that this function is undefined for negative values, including 0. So write yourself a note. The domain of a logarithmic function is from 0 to infinity, right? Not including 0. All right, so now, we already mentioned it, but notice there is a vertical asymptote at x equals 0. The domain is restricted to be x greater than 0. The x-intercept is 1, 0. Remember, regardless of the base. The graph will always pass through the point a, comma 1, or in our problem, 2, comma 1, because the base was 2. And then, once again, all transformations of functions, shifting, stretching, shrinking, reflecting, are applicable to logarithmic functions. So just like the ones that we talked about with exponentials. So, for example, f of x equals the log base 6 of x. All right, so this graph is always going to go through what? Well, it's going to go through 1, 0. It's going to go through 6, 1. And then, well, you could do one of two things. You could go through either, 36, 2, right? Remember, that would be the log base 6 of 36. And what does that mean? That means 6 to the what is 36? That's 2. Or the other one that usually I use is going to be 1 over 6, comma, negative 1, right? Because that would be the log base 6 of 1/6. And that says 6 to what power is 1/6? That would be negative 1. So what are the points to use? Well, I would say you would use the points that I have mentioned. Points that I have mentioned here, a1, 1, 0, and then 1 over a, negative 1. I think those would be the 3 points that are easiest to use for all. So, the graph, 1, 0, 6, 1, and then 1/6, negative 1, and then we have this curve and the vertical asymptote. All right, so now on these, let's find the domain, vertical asymptote, x-intercept, and then sketch a graph. All right, so the first one, log base 3 of x plus 5. Now that plus 5 is added on the outside of the function, so that is going to represent a vertical shift up 5 units. Not to be confused with over here, this is going to represent a horizontal shift to the right 3. Down here, this is going to represent a horizontal shift to the left 3. And this doesn't have any shifting. All right, so the first one, we're going to start with the log base 3 of x, and then we're going to add 5 to the y value. We're going to shift up 5. All right, so first of all, the log base 3 of x. All right, so remember, we always have 1, 0, then we have 3, 1, then we have 1/3, negative 1. So now, if I shift these up 5, I'm going to get 1, 5. I'm going to get 3, 6, and I'm going to get 1/3, comma, 4. All right, so now let's plot these. All right, 1, 5, 3, 6, and 1/3, 4. So that would be here, and we still get this. Okay, now notice, when I went up 5, I added 5 to the y value, right? I said y plus 5. Okay, so remember the vertical asymptote is an x equals, right? It's x equals 0. So I'm not changing the vertical asymptote. So that's still the asymptote, which means the domain is still x greater than 0. What about the x-intercept? There is an x-intercept here, right? So the x-intercept, remember, is the value of y. Sorry, the value of x when y is 0. So that means that the function is 0. So 0 would equal the log base 3 of x plus 5. So how would I solve this for x? Well, if I subtract 5, I get negative 5 equals the log base 3 of x, which means that x is 3 to the negative fifth. So the x-intercept is 3 to the negative fifth, or 1 over 3 to the fifth. All right, what about this next one? We're going to shift to the right 3. So we're going to start with our basic points. So that would be 1, 0. That would be, remember, the base is 2 here. So 2, 1, and then 1/2, negative 1. All right, so 1, 0. If I shift that to the right 3, I get 4, 0. 2, 1. If I shift that to the right 3, I get 5, 1. If I shift 1/2 to the right 3, I would be adding 3, so that'd be like 7/2, negative 1. So let's plot those. So 4, 0. Notice that is the x-intercept as well. 5, 1. And then 7/2. Remember, 7/2 is 3.5, negative 1. Now, the asymptote originally was x equals 0, so if I shift it to the right 3, the x value changes, and so it becomes x equals 3, which now means that my domain is x is greater than 3. And so we get this graph, which has the vertical asymptote. All right, the next one. Okay, we already said we have the left 3 shift, but then we also have this negative sign, which is a reflection over the x-axis. So we have the left 3, which is changing the x value, and then we have the reflection, which is changing the y value. So it doesn't matter what order we do them. All right, so I'm going to start with my 3 basic points. 1, 0, 5. Remember, 5 is the base, so 5, 1, and 1/5, negative 1. All right, so now let's do the shift left first. So if I shift 1, 0 to the left, 3, I get negative 2, 0. 5, 1, shift to the left 3, I get 2, 1. And 1/5, negative 1, if I shift 1/5 to the left 3, that means I'm taking 1/5 and subtracting 3. And so sometimes people make a mistake. 1/5 minus 3, so that'd be like subtracting 15/5. So I get negative 14/5, right? Or negative 2 4/5, comma, negative 1. So that's the shift. Then we reflect. So what does that mean? Reflect over the x-axis. That means make the y value the opposite. So negative 2, 0 stays as negative 2, 0. Then 2, 1 becomes 2, negative 1. And negative 14/5, negative 1 becomes negative 14/5, positive 1. So now let's plot those things. So negative 2, 0. 2, negative 1. And negative 14/5, positive 1 would be up here. Remember, negative 14/5 is negative 2 4/5, so that'd be right here. So now we have this function that looks like this. Remember, it was reflected. And then our asymptote got shifted to the left 3. So we have x equals negative 3. And remember, that means our domain is x is greater than negative 3. All right. And then the last one here. All right, so I've got log base 10 of negative x. So what does the negative do? Remember, that is a reflection over the y-axis. So if I reflect over the y-axis, so we start off with 1, 0, then 10. Remember, the base is 10, so 10, comma, 1. And then we have 1/10, negative 1. So now, reflect over the y-axis. That means we make the x value the opposite. So negative 1, 0, negative 10, 1, and negative 1/10, negative 1. All right, so now that means that the graph had been going to the right originally, but now it gets reflected, and now it's on the left. So negative 1, 0, negative 10, 1, and 1/10, negative 1. And so we get this graph. And now the asymptote, once again, remember, there was no horizontal shifting, so the vertical asymptote is still x equals 0. And the domain, look at the picture, the domain is x is less than 0. So I know that there was a lot to do there in the graphing, but hopefully you followed along. And then your homework, remember, is going to be the 3-1 and then the 3-2 assignment.